Hello and good afternoon, CSI 158, Section 841 and 847 students at Anne Arundel Community College for the Spring 2014 second 8-week term. Today's PacketTracer tutorial is going to provide you with the solution set for PacketTracer Activity 2.2.4.9, which is going to be configuring port security. So as you're already accustomed to, here's our addressing table. And as it turns out, all of these addresses have already been assigned to the different devices. So really, the main portion of this activity is going to be for us to configure port security and to see what happens when a device, which is not in the MAC address table as a sticky MAC address, is introduced into a port that has the restrict option set on it. All right, so first off, it says access the command line for switch 1 and enable port security on Ethernet ports 01 and 02, or FA 01 and 02. So we're going to go ahead and open up the command line for the switch. As you can see, there's already been some information configured. So we'll go from user exec mode into privilege exec mode. From privilege exec mode, we're going to go into global config mode. And this is where we're going to use the interface range command. And the interface range command allows us to make changes to more than one interface at a time. So we'll do FA0/1, a space, the dash, and then the next port number. So this would change fast Ethernet ports 01 and 02. If I were to change it to 12, it would be ports 01 through 012 inclusive. But we're just interested in 01 and 02 right now. So I'll enter the no shut command to make sure that those interfaces are up. And then we're going to go ahead and add the switch port mode. We'll turn these into access ports, which are used for hosts. And then we're going to go ahead and do the switch port security. And then we'll do the switch port security, and we'll take a look at the options that we have here. So we have MAC address, maximum, and violation. And I'll scoot my window just a little bit here to the right. So it says set the maximum so that only one device can access both fast Ethernet ports 01 and 02. So we'll go with maximum, and then you could have up to 132. And so we'll go ahead and select 1, because that's what we're being asked for. All right, it says secure the ports so that the MAC address of the device, or a device, is dynamically learned and added to the running configuration. And so here, let's come back a little bit, and we'll take a look at switch port security, MAC address. And this is where we could actually manually enter in the address, or we want it to dynamically learn the address. So we're going to go ahead and say MAC address sticky. And what that means is the first frame that that port receives from the host that's plugged into it, it's going to look into the source MAC address, and that's the MAC address that will be affiliated with that port. So we've entered that command in. Let's take a look now. It says set the violation so that the Ethernet, or the fast Ethernet port 01 or 02 are not disabled when a violation occurs, but packets are dropped from an unknown source. Now this is typically can be a little confusing for some students new to port security, because if you remember from the reading in Chapter 2, there are basically 3 violation modes that we can choose from. And so let's get those violation modes displayed here. And so we'll take a look at violation, and you can see we can choose protect, restrict, or shut down. So by default, the default action is to shut that port down. And what will happen is that port will be put into an air disabled state. And I'm going to demonstrate this after we complete this lab by making a change to the configuration, but we want to cover that right now because that's not going to be the option we use here. It's either going to be protect or restrict. And so typically where students become a little confused is the difference between protect and restrict. And really, the only difference between those two is that in restrict mode, a notification gets sent that a security violation has occurred, whereas in protect mode, that notification is not sent. So protect mode does not send a notification that there has been a security violation. Restrict does send a notification that there has been a security violation. And that is the primary difference between those two modes. All right, so we're going to go ahead, and if you look over here down in the right, you can see the completion percentage. It shows 46 out of 100. So if I enter in protect, which is not what it's looking for here, you'll notice that the completion mode doesn't increment. And that's how I know that that's not the mode that it's looking for. Because again, this is a little vague. It's basically stating that either protect or restrict is valid here because it doesn't specify whether it wants a message to be generated. And so we'll back up a little bit here. We'll change it to restrict, and then keep your eye here on the completion percentage, which is going to increase exponentially. When I put restrict in and hit enter, you can see that the completion percentage went from 46 to 62. And so that's how we know that it's looking for restrict. Again, the difference, protect does not send a notification message. Restrict will generate that notification message. And shutdown is the default port violation status that will be assigned to a port unless we select either protect or restrict. Okay. So now it says disable all of the unused or the remaining unused ports. So if I do a do show run, you'll see that we've got Fast Ethernet 03 all the way to 024, and then we have 2 gigabit Ethernet interfaces, 1.1 and 1.2. So I'll exit out one level. So again, we're going to use our interface range command. I'm going to do FA 0/3, and you need that space in there. And let's see what happens if I don't put the space in there. And I try to go FA 03 to 24. It works here, but on iOS, and actually it doesn't look like I'm going to be able to get into a switch right now, but typically on iOS, it's going to look for a space between those characters. All right, so we're simply going to shut down those ports. And as you can see, the score immediately incremented again to 84. All right, so I'll exit out here, and then we're going to go interface range GI 11 to 1.2, and we'll shut those down as well. All right, so now all of the ports have been administratively shut down as we've been asked to do. So now let's go ahead and type end to end our configuration session. We're going to go ahead and do a write memory to save our config, and now let's do a show run and see what we've got here. So as you can see, Fast Ethernet 01 and 02 have been fully configured with the port security as well as the MAC address sticky. And what's going to happen if there's a violation is the packets are simply going to be dropped, and since it's restrict mode, theoretically it would generate a message that we could send off to a syslog server. Okay, so we're going to leave this guy right here, and let's take a look at what we need to do next. So from PC1, ping PC2. So we'll come over here, pull up our desktop. I'm going to go ahead and ping 10.10.10.11. So from PC1, I can ping PC2. So we've already verified that port security is enabled. So now it says attach rogue laptop to any unused switch port, and notice that the link lights are red. So I'll choose a straight through copper cable. We'll go from Fast Ethernet 0, and I'll just choose Fast Ethernet 03. So as you can see here, we've got red dots, and what that means is that the port is shut down and there's no connectivity at all. Typically what we would expect if this port was operational is that the laptop port would be green, and then this would be orange for about 30 seconds while spanning tree converges, and then it would also turn green. So let's continue through. Enable the port and verify that the rogue laptop can ping PC1 and PC2. So let's enable Fast Ethernet 03. So we'll go from privilege exec into global config into interface configuration mode, specifically interface Fast Ethernet 03. I'll type no shutdown, and that brings the port up. And as we previously discussed, as you can see, the laptop immediately goes green, but now we're waiting for spanning tree to converge. And we haven't talked about port fast, but if port fast was enabled, this would go green almost immediately. So we're going to wait for spanning tree to converge, because right now And let me see if I can quickly get the laptop up and get the desktop and run a quick ping command. While spanning tree is converging, I am not going to be able to ping PC1. And these, well, it's going to work. It'll work now. It just went green. So the first one will time out, but then the rest will work because spanning tree finished its convergence. So I can ping PC1, and now I can ping PC2. So from that rogue laptop, I'm able to ping PC1 and PC2. So it says disconnect PC2 and connect rogue laptop to PC2's port. Verify that rogue laptop is unable to ping PC1. All right, so let's take a look at the switch first here, and let's do a show run. And as you can see, when we ping those different hosts, and they pinged each other, that the MAC address sticky has now been placed into the running config. And this is important because it's now part of my running config. So if I were to type write mem and then reload this switch, I've written the running configuration and written it over to the startup configuration. So when this switch comes back up, let's confirm that by doing so, we are able to keep those MAC addresses in here with the MAC address sticky feature. And as you can see, these MAC addresses both survived the reload of the switch. So Fast Ethernet 03 is still enabled, but the MAC addresses for both PC1 and PC2 are now associated with their respective ports. So spanning tree is going to finish to converge over here. And what we want to do now is we're going to go ahead and disconnect PC2. And I'll connect PC2 to FA024. And you can see the ports are red because FA024 is shut down. And it wants us to disconnect the laptop and put it into Fast Ethernet 02, which we've done. And now we're going to go ahead and wait for about 30 seconds while spanning tree converges and that port comes online. The task that we need to complete is we need to verify that the rogue laptop is unable to ping PC1. So it's definitely unable to ping it now. And so while that's coming up, if I were to type in here, show port security, I would actually get a listing of the ports where port security is enabled. It would show me the maximum secure address count. So we've already indicated that we only want to allow a single MAC address to be associated with that port. How many current addresses are associated? It shows 1, right? So that these have been, the ports here have been, have had something plugged into them. And then the security violation count. So there haven't been any violations yet. And then what is our security action? It's basically restrict, which is drop packets from unknown source MAC addresses. All right, so it looks like the rogue laptop is now fully connected here. We've got green lights on both ends. So let's pull the rogue laptop up and let's try to ping PC1. So I ping 10.10.10.10, and as you can see, I'm unable to ping PC1. So if I come back over here and I run the show port security count again, you'll see that FA02 now has 3 violations listed. And let's see if that increments to 4. And there's no coincidence that the reason it's received 4 frames is that we've tried to ping, right? And ping sent out 4 different requests. And so let's ping again. And what we should see is that restriction, the security violation count, should continue to increment for each frame that it's receiving with an unknown source MAC. And specifically, that source MAC that's unknown in this instance is the rogue laptop. Because remember, Fast Ethernet 02 has the MAC address for PC2. And so let's run that again. And as we would expect, the restrict count, or the security violation count has now incremented to 8. So for every frame it receives that's in violation of the sticky MAC address the port security policy we've applied, it's going to increment this counter. So let's go ahead now and continue on. It says display the port security violations for the rogue laptop, for the port rogue laptop is connected to. So this is one way to do it. We could also add in interface FA02 and take a look at the specific interface to see anything else that's on here. So the port security is enabled, the port status is secure and it's up, and again remember it'll remain in the up state, it's just going to drop packets. The mode the violation mode is restrict, 0 minutes of aging time, absolute aging time, secure static address aging is disabled, shows us our maximum MAC addresses is 1, total MAC addresses associated right now is 1, configured MACs, we haven't configured any, so it's 0, sticky MAC addresses 1, and then the last source MAC address is 0002 4 Alpha 42 Charlie 51 Charlie. So now that MAC address, is it from PC2 or is it from the rogue laptop? So let's shut this down. We'll pull PC2 up. And what happens if we do an ipconfig-all? We should see the MAC address, and as you can see, the physical address or the MAC address for PC2 is not listed. So, if I were to come back over to the rogue PC and type ipconfig-all, we would expect to see that this MAC address for the rogue PC will match the last source address. So this is very important because it will show you the last source MAC address. So in effect, if it was a rogue device that had been plugged in, that's the MAC address that will be listed here. And again, security violation count is 8. So those two commands again were show port security, and that gives you sort of an abbreviated look of everything, and then show port security, and you can list the interface and FA02 to see some more information. Okay, so disconnect rogue laptop and reconnect PC2. So we'll disconnect rogue laptop here, and we'll put him back in FA03. We'll take PC2 and put it back in Fast Ethernet 02, and we're going to go ahead and let spanning tree converge for these guys. And what we're going to do lastly, and you can see our completion percentage is 99 out of 100. So we're going to disconnect the rogue laptop, reconnect them, and then verify that PC2 can ping PC1. And so as soon as this is finished, we'll pull up PC2 here, pull the command prompt up, and I'm going to ping 10.10.10.10. All right, so spanning tree is converged. And we are fully able to ping from PC2 to PC1. And the reason that PC2 is able to ping PC1, but the rogue laptop is not, is because, again, on the switch, and we'll take a look at FA0/2. Oh, okay. Yeah, so it doesn't look like it supports that command, so we'll just do the full show run. So on FA02, let me make sure. Yeah, I had FA02 in there. Okay. So again, when we set up the MAC address sticky, that meant the first device or the first source MAC address received in a frame on that port, that is the MAC address that's going to be associated with that device. So as you can see, the MAC address here was the 0001, not the 0002 of the rogue laptop. So this MAC address was dynamically learned when that port received the first frame. It looked into the source MAC address, and then that is the MAC address that has been associated with this port. So any other device that's plugged in here that does not have that MAC address, this port is simply going to drop those frames when it inspects the source MAC address field in the frame. All right, so our completion is still 99 out of 100. So let's take a look and see, and check our results and see what we're missing. All right, so everything looks good all the way down to Fast Ethernet 03, because we left that up for the rogue laptop. So we'll close that, we'll pull up the switch, we'll go into global config mode, into interface config mode, and I will shut that port down. All right, and our completion percentage has changed to 100. Once again, this has been PacketTracer Activity 2.2.4.9 for Anne Arundel Community College students taking CSI158 sections 841 and 847 for the spring 2014 semester. I hope you found this video tutorial educational and helpful, and hopefully this has given you an idea as to exactly what port security is and what it can do. And so before we break away, I had commented earlier that what we are able to take a peek at here is if I were to do a show run, oh whoops, sorry. If I was to do a show run, you can see that right now the violation mode is restrict. But what happens if I were to do the interface range command on FA01 and 02 and change that to switch port security violation and shutdown, right? So we've seen what restrict can do. Let's take a look at shutdown. Most importantly, it's very interesting when you do a show run, you'll notice that the port security violation mode is not shown here. And that's because shutdown is the default. And so that's something to be sure you pay attention to. So if you see that switch port security is on, but you do not see a violation statement, that's an immediate indicator that the port will be air disabled and shut down when a violation has occurred. And so let's go ahead and do that with our rogue laptop and PC2. So as you can see here on FA02, it still has the MAC address because MAC address sticky is still in effect for PC2. If I come over here and let's disconnect that and we'll put it in 04, and I'll take the rogue laptop and put him in 02. So we're going to go ahead and let spanning tree converge here. As you can see, the interface has changed its state to up. So while that's converging, let's take a look at the show port security command. As you can see now, the violation mode or the security action no longer says restrict, it says shutdown. And if I do a show port security on FA01, oh I'm sorry, show port security interface, FA01, you can see now that it shows shutdown as the mode. If I look at 02, the same thing, right? And as you can see here, the last MAC address that this saw was PC2. So now let's try to ping, and this is going to generate traffic over to PC1. And what you're going to see, and let me slide this over here if I can, you're going to see the switch port shut down immediately, and you're going to see that interface go red. So as you can see, as soon as I hit enter, before we even received any feedback, that port immediately shut down. So now that link is red, and as you can see, it's also red at the rogue laptop because, again, the port has been shut down. We've received a message here to the console telling us that the state has been changed to down, right? Administratively down. So if I do the show port security now, as we would expect, the count has incremented to 1. And the reason that it's not continuing to increment here is because, again, on the very first frame that it receives, when it looks at that source MAC address, if it is not a match, the port is immediately shut down. And so what that implies is that if the port is shut down, it's not receiving any more frames. So those requests are going to time out, but those frames are never making it to the port, and so that is not going to increment. And so that's also something to keep in mind, is that when it's in this shutdown state, and I'll run another ping command here, and then we'll come back and take a look at the show port security. As you can see, it's not going to increment because the port is going to get shut down immediately. And so that's another subtle difference between port security violation mode of shutdown as opposed to the port security violation mode of restrict. And so let's go ahead and take a look at the interface. So if I do a show port security interface FA02, you can now see here that the port status is secure shutdown, shows us the violation mode, and again, it still does us the favor of telling us, hey, this is the MAC address that I last saw before I went into this shutdown state. And the security violation count here, same thing, doesn't increment. So now, what if I do a show run? As you can see, we still don't have the violation mode is not going to be displayed, but we know that because switch port security is on, the default mode is shutdown. But the port is actually shut down right now, so I can't do anything. So if I were to come back over here and let's say I wanted to re-enable that port, because it's in the air disabled state, I would have to go into the interface configuration mode. I would have to shut the interface down. It's already shut down, and then no shut that interface. Now you'll notice it brings that interface back up. Spanning tree is converging. So let's do a quick test here. Let's see if spanning tree converging is not going to recognize a violation. And as you can see, even when spanning tree is converging, right, and the port links aren't green, as soon as it receives a frame on that port, that frame is going to be shut down. So again, if I do the show port security, you can see that it is now, there's a security violation. If I do a show port security interface FA02, and that interface is now in secure shutdown mode, right? And so those are also some of the commands that you can run that we have been running to show us what the status of those interfaces will be. Okay, so I'll go ahead and wrap the video up here. Again, I wanted to show you a little additional information there, especially about the shutdown command, because there are some subtle differences. Most notably, something that's confusing for new students is when they see this, they don't make the association that, oh, it's in shutdown mode because that's the default mode. They're looking for a violation, port security violation statement to try to correlate that to what the mode may be. But again, the default mode does not show that. All right, I hope you found this video tutorial helpful, and best of luck.